Hey guys, Mr. Middleton here. Today we're going to look at evaluating functions. At the end of this video, you should be able to evaluate functions using function notation and otherwise. Alright, so let's start off with some review. Recall that from Unit 1, when we evaluated an expression, what that means that we do is we plug in a known value for a variable. And so here's a few examples. If we have 4x plus 2, we're going to evaluate when x is 10, plug in 10 for x, and simplify. So 40 plus 2, 42. Okay, we can do the same thing here, plug in 16 for y, 16 minus 4 over 3, that's 12, 12 divided by 3 is 4. Okay, and then same thing here, plug in 2 for x, negative 8 times 2 minus 4, negative 16 minus 4, negative 20. Notice every time I plug it in, I'm plugging it in parentheses to make sure that I'm keeping everything in order, how it's supposed to go, and keeping the operation happening to it the same. Okay, alright, so we'll use these while we're dealing with functions, and more specifically as we're evaluating function rules. Okay, and a function rule is just an expression that represents or describes a function. Remember, a function is a relation where every x has exactly one y. Every input has exactly one output. Alright, to write an equation in function notation, you only need to change the y to f of x. Okay, the f is not a variable. Okay, please do not try to solve for f. It represents the name of the function. So the f is not a variable. It represents the name to the function. So and all that means is here. In this problem, if we have y equals 3x minus 2, we can write that in function notation as f of x equals 3x minus 2. Here, if we want to write this in function notation, we'd say f of x equals negative 4x plus 6. Okay, and so we basically say the function f, this is the function when x is whatever it is. In this case, x is just x. Okay. When evaluating a function, though, you'll see that f of x is going to be replaced with something like f of 2. This simply means that you need to replace the x with the number 2 in the function rule. Okay, so very much like evaluating. So here we have f of x equals negative 5x plus 25, so they named the function for us. And they said find f of negative 2. So find the function f when x is negative 2. And so what we do then is we say, okay, f of negative 2, just naming it again, equals negative 5. And then I'm going to plug in negative 2 for x. Negative 5 times negative 2 is 10. 10 plus 25 is 35. And so I have f of negative 2 equals 35. I can do the same thing here. F of 10 equals, plug in 10 to my parentheses, minus 4. 10 squared is 100. 100 minus 4 is 96. So f of 10 is 96. Okay, and the naming is important, and the reason is so if we have multiple functions, we're able to look at those at the same time. Okay, so here, see. Okay, so here we have f of 8 plus g of 3. Alright, so I have f is named here. I'll plug that in. Okay, so f of 8 plus g of 3. F of 8 is going to be negative 8 plus 2 plus g of 3, which is 3, and plug in 3 for x for g, plus 4. So I have negative 8 plus 2, which gives me negative 6. 3 times 3 is 9. 9 plus 4 is 13, plus 13. Negative 6 plus 13 is positive 7. So I know that f of 8 plus g of 3 equals 7. Alright, you can try number 4 out for yourself. Try that out. Bring that for when I check your notes. Okay, looking at the back side. Okay, so here's a direction that you'll see often. The direction will say evaluate the function rule. Make sure this is all in there. Evaluate the function rule to find the range of the function for the domain -4, 0, 3. So to translate this for you so you understand what this is saying, is I've given you 3 x values, or inputs, either way that you want to think of it. And I'm asking you to give me the 3 y values that go with them. Okay, so this one says, hey, here's the function f. Try it out for -4, 0, 3. Tell me what the y values are. All right, and so we can do that. We have f of -4 here. 2 times -4, absolute value of that, minus 15. So that's 8 minus 15, which gives us -7. So f of -4 is -7. We have to do that same thing for 0. F of 0, 2 times 0, minus 15. So that's 0 minus 15. F of 0 is, f of 0 is -15. Make sure I have these so I can find them later. And then I'll do the last one, f of 3. F of 3, absolute value of 2 times 3, minus 15. 6 minus 15 is -9. Yes. So I know that f of 3 is -9. Alright, so I have all these together, and then I'm just going to write them as a domain, as a range. So my range will be -15, -9, -7. Okay, so we have those 3, and now we can do that same thing for this one. Again, we're just plugging those values in. I'll do this a little bit quicker here. Plugging in -4 squared plus 5, 16 plus 5 is 21. Plugging in 0 squared plus 5 is 5. Plugging in 3 squared plus 5 is 14. Okay, and so my range for the second one will be 5, 14, 21. Okay, so showing you exactly how it's done, doing it for you there. Okay. Actually, make sure you pay close attention. Notice that this negative went in parentheses and we squared it. If it were negative already there, it would come out to be a negative number, but it did. Okay, so couple more examples. I'll do one more with you, and then I'll have you do D on your own. Evaluate the function rule to find the range of the function for the domain -6, 3, 9. Remember, all this is saying is plug in these x values to see what y values are that go along with it. And so we'll do that here. So we have y equals 3/2 -6 plus 1. That's one of them. Y equals 3/2 3 plus 1. That's the other one. And then y equals 3/2 9 plus 1. Okay, so notice that all we're doing is plugging in these x values that they gave us, and we're going to see what y ends up being. So that's -18 divided by 2 is -9. -9 plus 1 is -8. We have 3 is 9. 9 divided by 2 is 4.5. 4.5 plus 1 is 5.5. Let's say 5.5. Okay. And then we have 9 times 3, which is 27. 27 divided by 2 is 13.5. 13.5 plus 1 is 14.5. Okay, so these are our values. So I'm going to put them in a range from least to greatest. Actually, it's already there. -8, 5.5, 14.5. Okay. All right, so you guys do that for D. So you have 2 problems up to this point that you should be doing. D here and the last problem on the first page. All right, so now these function rules we can do out on their own as their individual problems, but most of the time, at least later as we continue in math, we'll see our function rules kind of adapt to being used mostly in creating tables and completing tables that we'll be using for graphing. And so here, we're going to complete each of the following tables for the given function rule. This idea will be used in the next lesson, so it's a good idea to understand what is happening here. So basically we're doing this up here instead of, they're still giving us the x value. We're going to plug the x value in, and we're going to see what comes out for y. Again, you're plugging it in, you're going to evaluate it, you're going to simplify all the work that's necessary to do that. So I'll plug this in. -4 times 1/2 is -2. -2 minus 3 is -5. Okay, plug this in. -2 times 1/2 is -1. -1 minus 3 is -4. 0 times 1/2 is 0. 0 minus 3 is -3. 2 times 1/2 is 1. 1 minus 3 is -2. 4 times 1/2 is 2. 2 minus 3 is -1. Alright, so they gave me the values. Doesn't necessarily mean anything, but I feel pretty confident that my pattern holds up. You can plug it in and check and do all that stuff to make sure you plug those values in correctly. Okay, we'll do the same thing here. 2/3 times -6, that's, just make sure I go through one of these, I guess, with you. -6 times 2 is -12. -12 divided by 3 is -4. 4 plus 4 equals 0. Okay, and so that's what we're doing each time. So doing that again, that's -6 divided by 3, which is -2. -2 plus 4 is 2. 0 times 2/3 is 0. 0 plus 4 is 4. 3 times 2/3 is 2. 2 plus 4 is 6. 6 times 2/3 is 4. 4 plus 4 is 8. Okay. And then the last one here, if you feel like you got it, you can just do it on your own. If not, stick along with me. Alright, I kind of made a point of this up here with number 2, making sure that you pay attention to where the negative sign is, and so we get to practice that on this problem. So here the negative sign is outside of x, and so if we look at this, when we plug in -3, we'll have -3 squared plus 5. -3 squared is 9, but then negative that makes it -9. -9 plus 5 is -4. Okay, do the same thing, -2, that's -4. -4 plus 5 is 1. 0 becomes 0. 0 plus 5 is 5. 2 squared is 4. The negative of that is -4. That becomes 1. 3 squared is 9. -9 plus 5 is -4. Okay. And so all that is us plugging in the values that we were given for the x and getting y. Okay. So that's evaluating the functions using a function rule, making sure you can use function notation. Make sure that you guys do this problem D here and this problem 4 on the front when you bring it in to me and I check your notes. Alright, see ya. Bye.